So this is half wave rectifier. This is a single phase half wave uncontrolled rectifier. I call this as an uncontrolled rectifier because I use diode in the rectifier circuit. You can see here, rectifier circuit is very, very simple, very easy. So we know the property of diode already, right? You have studied about this. So this is called anode and this is called cathode. So you apply the positive, whenever you apply positive here and negative here, then this diode will be in forward bias. But if you reverse the polarity, minus here and plus here, then this is in the reverse bias. Under reverse bias, this will act like a open circuit. It will not conduct. But under forward bias like this, it will conduct the current. It's a short circuit. So this is the property of diode. This property we are using in these rectifiers. So we know AC current means the AC current will just alternatively, it will change from positive to negative. Positive to negative. It will just repeat again and again. So here as diode contact current in one direction and block in other. So we know that. So it will, if you apply plus and minus this way, it will conduct. If you change the polarity, then it will not conduct, it will block. So this is the property of the diode. So now if we apply AC voltage here as the input to this diode, then what will happen? During this positive cycle, then this diode will be short circuited during the positive cycle. So during the positive cycle, we are applying the plus here and minus here to the cathode. Then the current is passing. Then we get at the output like this. And during the negative half cycle, so we inverse the polarity, automatically it inverse the polarity to this diode. So it will be minus here and then, okay, let me change the color. It will be minus here and then the plus here. So it's in reverse bias, so it will not conduct. So then you don't get anything at the output, it's 0. And then again the cycle repeats. So in the next cycle already here now, so again positive, then this diode conducts. Then this is, so you get the output. You get the output at the across this load resistor. The negative half cycle, this is diode is acting like a open circuit. There is no current conduction. That's why you don't get here anything. So here also you don't get anything. So this is called half wave rectifier. So you can see here when connected with the AC voltage, diode only allows half cycle passing through it and hence convert AC into DC. So now you see here the voltage is only in the positive side. There is no voltage in the negative side at all. So it's becoming a direct current now, but it's not a pure direct current. It's a pulsating direct current. Okay, so as the half of the wave get rectified, this process is called half wave rectification. So as I mentioned here, you can use either diode or SCR. You can use either diode or SCR in this circuit. If you use the diode, then you will get like this. If you use the SCR, you can fire this. It will you can fire the gate of this SCR anytime, and you can reduce or increase the width of each pulse. So for example, you can, if you fire from this, for example, here, let's say this is alpha equal to 30 degree. So first of all, you should know about the degrees. In any wave, one full cycle, it's starting from 0, let us say, and one full cycle is 360 degree. So here it's called pi. This is 180 degree. Pi is equal to 180 degree. This is 2 pi. It's equal to 360 degree. So in between, if you divide into 30, 30, 30, Then you will have, for example, here is the 30 degree and here is the 60 degree, here is the 90 degree and so on. So you will have 180 degree and here also. So it means here this diode is conducting first 180 degree of the cycle and it blocks the second part of the 180 degree. So anyway, so that is the diode property, but in this SCR, you can fire anytime. For example, instead of starting from 0, you give the gate signal only at 30 degree. Then at the output, here at the output, the output will start only from 30 degree. So here there will be no output because the SCR is not conducting the first 30 degree. You are giving this gate voltage only after 30 degree or at 30 degree. Alpha is equal to 30 degree. Then it start to conduct. Then here is okay. And the same here. So the same cycle will repeat everywhere. And you can also increase or decrease this firing angle. By increasing and decreasing, you can change the output voltage DC. So what we are doing actually at the output, after we get this one, we are making an average value of all these pulsating DCs. So if you reduce the pulse width, for example, now I am putting 30 degree, right? So at the output, maybe as the average, I am getting plus 24 volt. So now I reduce or I increase the alpha value to maybe 60 degree. So instead of here, maybe it start to conduct from plus 60 degree. So you see here, half of this pulse is already, we are not getting any output because I am firing only at 60 degree. So the output starts from 60 degree like this. You see the pulse width got reduced, obviously. So when you make the average value, then the average will go down maybe to somewhere else. So this is a very based on our common sense, like how the mathematics works. So if you add 10, 10, 10, 10, and then if you make average, for example, 10 plus 10 plus 10 equal to 30, right? The average is what? 30 divided by 3. How to calculate the average normally? We are just adding all the numbers divided by the number count. So here 10 plus 10 plus 10 is 30, 1, 2, 3. So 3 numbers. So 10 divided by 30, so the average is 10. But instead of having the 10 width in the first part, now the width got reduced. Maybe the width is only 5. So now I have 5, 5, 5, and then 15 divided by 3. So it's going to be 5. So average got reduced automatically when you reduce the number value. So here you are reducing the output by controlling the SCR firing angle. So everything is based on this firing angle we are talking about. So we can also call this as a omega t. So omega is equal to 2 pi f, right? So that you know that. Okay, so now we will move on. So half wave rectifier, positive half cycle causes current through diode that causes voltage drop across the resistor. But we are wasting negative half cycle of the input voltage. So diode is conducting only the positive and it completely blocks the negative half cycle. But we are supplying this input voltage here. It's only conducting half and then wasting the second half cycle. That is why the efficiency of this half wave rectifier is very, very small. It's much less. So you can see it's about 38% or 40% the efficiency of the half wave rectifier. So here you can see this circuit. This is the normal half wave rectifier. But in practical, instead of applying the input like this, we are using some kind of transformer and then we are stepping down the AC and then we are applying to this diode and then we have the load. Okay. So, and also the TUF, it means transformer utilization factor. This is also much less in this half wave rectifier. So this is the definition of TUF. You can read that. And ripple factor is quite high. It means a lot of ripples here. It's not a pure DC. And also the half wave rectifier is, that is why half wave rectifier is normally not used as the power rectifier circuit in practical applications. Okay, so this is the half wave rectifier. It's not really useful in practical applications. Then it means it's because of the very low efficiency. We are wasting half cycle here. Then we need to move to the full wave rectifier.